chemical reaction convert substance into other materials with different properties. Much of our study of chemical reaction has to do with the formation of new substance from a given set of reagents. However, it is equally important to understand how quickly chemical reaction occur. Chemical kinetic is the area of the chemistry that deals with the study of the speed in which a chemical reaction occurs. The word kinetic suggests movement or change. Chemical kinetic refers to the reaction speed, which refers to the change in the concentration of a reagent or a product with respect to time. An example could be the airbag in the vehicle. The reaction must be quick enough to fully open in seconds.
The concentration of the reactants is a factor that influences the speed of a reaction. The higher the concentration of each reactant used in a certain reaction, the higher the speed with which the products are formed. This is because the higher the concentration there will be more options to collision between the molecules, therefore the faster the reaction speed. For example, the charcoal in a grill burns faster when you blow it. This happens because you are increasing the concentration of oxygen in this point. Also, when we burn a plate with ferric chloride, the more chloride there is in the container, the faster the reaction will be.
Reaction is proportional to the concentration of the reaction raised to a power, so it's advisable to talk about reaction order. In this case, we say that the reaction is of the first order, since the power at which the concentration is highest is equal to 1, Earth raised S cube. A cube is a second order reaction as well as following R raised A B. Then in general we can have R equal KAB, where N equal AB, N is the total order of the reaction. It is important to know that the order of reaction is extremely an experimental magnitude, which depends exclusively of the way in which speed relates to the concentration or reactants. Speed constant. A speed constant is a constant of proportionally that appears in a speed law. For example, k is a speed constant in the speed law dA slash dt equal a key. Speed constants are independent of concentration, but depend of the factors mainly temperature. Proportionally factor in the equation of speed law of chemical reaction. In chemical kinetics, the k constant in velocity equation is a function of t and p and is scale a velocity constant or velocity coefficient.
A limiting reagent is a chemical reactant that limits the amount of product that is formed. The limiting reagent gives the smallest yield of product calculated from the reagents available. This small yield of products is called the theoretical yield. To find the limiting reagent and theoretical yield, carry out the following procedure. Number 1. Find the moles of each reactant present. Number 2. Calculate the moles of a product formed from each mole of reactant. Number 3. Identify the reaction giving the smaller number of moles of product. This reaction is the limiting reagent. And number 4. Calculate the grams of product produced by the limiting reagent. All of this is the theoretical yield. Half-life is defined as the amount of time required for the amount of a substance to be reduced by 50%. Half-life a useful concept if its value does not depend on how much material is present. Such a decay process is called as first order. Nuclear decay is the first order. Let's say A substance undergoes first-order decay with half-life is equal to 1 hour, and that we begin with 60 units of the substance.